Okay, guys, let's take a look at section 1.3 where we're dealing with word problems. You know in life you're going to attack word problems. You know that you're going to run into situations on the job, situations in life where you need to come up with some mathematical equation or mathematical expression to solve the situation. There is no job out there where they say, let me give you a worksheet and I'm going to pay you $40,000 to just solve these equations in that worksheet. It doesn't exist. So we need to get really good at taking situations, turning them into mathematical formulas, and then being able to solve those situations. So students frequently will tell me, I'm really terrible at math, especially word problems. And then I'll say to them, well, if I would write the equation out for you that represents that situation, could you solve that equation? 9 times out of 10, they'll tell me, yeah, I can solve the equation. Well, what that means to me is that's not a problem with math. You're actually very good at math. It's a reading comprehension problem that you've got. We need to get really good at translating words into mathematical symbols. And so that's what we're going to do. We're going to solve several of these word problems and get very good at the translation so that you can get to the part where it's easy and you're solving the equations. So let's take a look at the first one. It says Heather bought a winter coat for $6 less than half its original price. Heather paid $65 for the coat. What was the original price? A lot of people get lost in all those words. Well, I can tell you, I'm the one with a master's degree, and I take word problems and read them very slowly. The biggest problem that people have is they just try to go too fast. So slow it down. What I do is I read it in its entirety like I just did, just to get a feeling for what's happening in the problem. And then I will take it sentence by sentence, breaking it down super slow. So I've read it in its entirety. I know that she's buying a winter coat. She's getting a discount. Yes, I love it when I get a good deal. So with discount situations, what happens? Well, you go up to the counter and they take the amount that you were going to pay and they take money off of that. What kind of mathematical operation is that? Sure, it's subtraction. So I know that somewhere, somehow, I'm going to be subtracting in this problem. I just got to figure out where it's going to happen. So now I'm going to take it sentence by sentence. And the first sentence says she bought a winter coat for $6 less than half its original price. Well, there's the subtraction. It's the fact that you're taking $6 off. But $6 off of what? It's $6 off of half the original price. Well, how do I show half of the original price? Key word is, it's not in there, but the key word is of. When you hear of, you should always think multiplication in math. Half of the original price means half times the original price. So the problem is, what's the original price? Do you know what that is? No, we don't. In fact, that's what's being asked. What was the original price? There's our unknown. When you have an unknown, you need to define it with a variable so that you can represent that unknown and figure out what it actually is. So I'm going to define that unknown, and I'm going to let P equal the original price. Sure, you could use an X if you want, but sometimes it's fun to get a little creative with it, and P helps me to remember it stands for price. So now we know we're going to take half of that original price, and remember, we're going to do half times the original price. So it's going to be half P. And then remember, now it says we're going to do $6 less than that. So that means take this half P and subtract 6 from it. So we've taken care of the first sentence. We've done everything we can possibly do with that first sentence. Now we're going to move on to the second sentence. And it says Heather paid $6 for that coat. Well, that means all of this should be $65. So how do you represent should be? Should be, was, is, will be, words like that always mean equals. So this is going to equal $65. That takes care of the second sentence. Now we've done everything we can possibly do with all the information that's in there. You did the hard part and did a fine job of it. So what I have here, whoops, erased just a little too much there. There's the equation that you know how to solve. We've talked about solving equations. Let's get to that good part now. So we're going to take the equation, and in order to solve it, remember, here's that wall, and I want to get everything away from this P. So what I'm going to do is I'm going to reverse the order of operations. In other words, if I knew what P was and I plugged that number in there, order of operations says that I would first multiply by half, and then I would subtract that 6. Subtracting 6 is the last thing that I said. That's the first thing I'm going to fix. So the opposite of subtracting 6 is adding a 6. And remember the idea of the pan balance, that your equation is a pan balance with the fulcrum and the equal sign right here in the middle. So what I do on one side, I have to do on the other to keep it balanced. If I add 6 over here, I better add 6 over here. Now negative 6 plus 6 cancels out. I'm left with a half p. And then on this side, 65 plus 6 is a 71. Now all I have to do is undo the multiplication by a half. How do you undo multiplication by a half? Sure, you divide by a half. But remember, dividing by a fraction is the same thing as doing what? Yeah, multiplying by its reciprocal. So I'm going to multiply by 2. And actually, I'm going to go for that because it's faster and it's cleaner. I'm going to go for the jugular, and I'm just going to go ahead and multiply by 2 on both sides. Now remember, when you multiply fractions, what do? You cancel in the diagonals. Remember, the x means multiplication, so I'm going to cancel in the diagonals. I'm going to cancel up and down, and then I'm going to shoot straight across. So I'm going to cancel here, and when I do, that leaves me with a p. And then on this side, 71 times 2 is going to be 142. Now, this is a real-world situation, so it's very important that we describe our units in here because for 2 reasons. One, you want the reader to know what you're talking about. Is that 142 coats? Is that $142? 142 what? It's $142. Very important that the reader knows that. Also, it's very important that the reader knows that you know that. We're setting you up to get ready for employment, and you want to impress your employer. You want to make sure your employer knows, hey, I'm smart. I know what I'm talking about. That's not 142 coats. It's $142. So be sure you always include your units to make sure that you are impressive and that they know what you're talking about. So that's how you attack number 1. Let's take a look at number 2. Number 2 says the grossman's total bill at a restaurant was $52.44. It included a 15% tip. What was the cost of the dinner before the tip? So I've read it in its entirety. I know what's happening here. It's date night. And at date night, I'm going to go out to a nice restaurant that includes tip. Well, the question is, how does tip work in a restaurant? What happens is you take the cost of the meal and then you add to that the tip amount. And when you do that, that gives you your final bill. So I know that I'm dealing with this mathematical operation here of addition. Now I've just got to figure out what exactly am I going to be adding up. So let's take it sentence by sentence. The first sentence says the grossman's total bill at the restaurant was $52.44. There's that word was. Remember, is, was, will be, are, that all indicates equals. So that final bill here equals $52.44. I've taken care of the first sentence. Everything that I can use out of there, I've used. Now, the second part of it says that 15% tip. Well, how does tip work? What happens is they take your bill and they do a percentage of that bill. So they take the cost of the meal. Of always means multiplication. So I'm going to multiply the percentage to the original cost of the meal. So I've got to figure out what is the original cost of the meal. Do you know what it is? No, sure don't. Matter of fact, that's what we're looking for because that final sentence says, what was that cost of the dinner before the tip? There's my unknown, so I'm going to define that unknown with a variable. So let's let M equal the cost of the meal before that tip. Before tip. So here in my formula, the cost of the meal is M, and now I'm going to add my tip amount. Now remember, can you add a percentage to dollars? No, it's a percentage. You can only add dollars to dollars. So this tip amount here, I need to turn it into dollars. I'm not going to add just simply 15 here because I cannot add a percentage. It's 15% of the cost of the meal. Of indicates multiplication. So it's going to be that 15% times this meal, but remember, I can't treat it in this form as a percentage. I need to turn it into a decimal. The way I do that is I take the decimal point that was in the back, kick it back 2 places. That's a 0.15. So now I've utilized all the information that I have in this word problem, and now I'm ready to solve the equation. So you've done the hard part. You set up the equation. Now it's time to solve it. So what I see here is that I have some like terms, and I'm going to combine up those like terms. An m plus a 0.15m. Now remember that m is a 1m. So 1m plus 0.15m is going to be a 1.15m. And that simplified the left side. And that's going to equal $52.44. At this point, I think we all know what to do. We're going to get that m by itself, we're simply going to go through and divide by 1.15. And 52.44 divided by 1.15 is going to be 4560. I'm running out of room, so I'll go over here. So my m is going to be 45.60. And remember, include those units to show that you know what you're talking about. Is that 45.60 chicken, 45.60 meals? No, it's $45.60 that this meal is going to cost. So there's the answer to that one. Okay, so let's move on now to number 3. I'm going to clear this out, and we're going to roll this down a little bit and pull up number 3. Number 3 says, at some hotels, senior citizens get a 20% discount on a room. If the discounted price is $78 for a room, what is the regular price? There's a few perks to getting old. Not very many, as I'm finding out with the bifocal lenses and the bad knees, but I do look forward to my discounts. So how does a discount work? You go up to pay your bill, and just like with that discount on the coat, they're going to subtract an amount off. So I know here that I'm dealing with subtraction. Some way, somehow, there is going to be a subtraction in this problem. I've read it in its entirety. I got a feeling for what's happening. Now I'm going to take it sentence by sentence very slowly. The first sentence says you get a 20% discount on that room. Well, how does that work? It's 20% of the original cost. There's that word of again, and of indicates multiplication. So I'm going to multiply 20% to the original cost of the room. Well, do you know the original cost of the room? No. Matter of fact, again, that's what we're looking for, the regular price. There's the unknown. We need to define that variable. So let's let P equal the original price of the room. And so like we said, what happens is when we go to pay the bill, they take that original price, they take the discount amount off of that. So we start with the original price, and now we're taking the discount amount off. Remember, it's 20% of that original price. Of indicates multiplication. So when I take 20% times the P, but remember, I cannot use it this way as a percentage. I have to turn it into a decimal. Decimal point started in the back, kick it back 2 to the left. That's going to give me a 0.20p. So that utilizes every piece of information in that first sentence. We need to look at the second sentence now. It says if the discounted amount, if the discounted price is $78 for that room. So there again, there's the word is, and is going to indicate that all of this is $78. There's your equation. You've used every piece of information in that problem that you can possibly use. Now it's time to solve that equation. Did a nice job of setting that up. Now we're down to the easy part. Remember, when you solve your equations, combine up your like terms, just like we did on the last one with the date night with the tip amount. This is a 1p minus a 0.20p. So 1 minus 0.20 is a 0.80, and that's going to equal 78. See, frequently here what students do is they leave out this p that's right here and just do a 1p minus 0.20. And that's not going to be right. I'll show you how that ends up in a minute. But at this point, with the 0.80p equals 78, what we all know what we're going to do at this point is very easy. We're just simply going to divide by that 0.80. And these will cancel to be a 1. And that leaves us with P equals, and 78 divided by 0.80 is going to be 9750. And once again, include those units. 9750 what? 9750 rooms, beds, what is it? It's dollars. So be sure you include your units in there. Now, like I said, I want to show you what frequently I see, because I don't want you making this mistake. A lot of times what students will do when they set this problem up, instead of making it 0.20p like you see right here, they'll take the p and subtract 0.20 because they completely forget that this is going to be 20% of the original price of the room. And they'll just simply take the 0.20 out. But when you do that and you add that 0.20 to both sides, then you get P equals 78.20. And that is not the original price of the room, because if you take a 78.20 and you subtract off the discount amount, you won't get to $78. They're not going to just simply take off 20 cents. That's not 20 cents. It's 20% of the original amount. So you got to be real careful about this. This is definitely not what you want to do. You want to set it up this way. So there's how you attack number 3. All right, let's move on and roll this thing up here and take a look at number 4. And I'm going to erase all this off of here. Okay, losing some room on the bottom, so number 4, I'm actually going to work it out above it. But number 4 says we have a basketball court, and it's a rectangle with a perimeter of 86 meters. The length is 13 meters more than the width. Find the length and width of the basketball court. I've read it in its entirety. I have a feeling for what's going on. I know I'm dealing with a rectangular basketball court. Well, I don't know about you, but for me, a picture is worth 1,000 words. I draw pictures all the time because it helps tremendously. So there's my rectangular basketball court. And the first sentence says I have a perimeter of 86 meters. Well, what's perimeter? Yep, sure is. It's distance around. So now the question is, how do you find perimeter? Well, you add up all the sides. I've got a width here, and I've got a width here, and I've got a length here, and I've got a length here. So if I add them all up, I've got a length plus another length plus a width plus another width. And it would be much faster to simply say, well, let's just double that length. And let's double that width. There's my perimeter formula that I'm going to be working with. So now I've taken the first sentence. Actually, I haven't taken this first sentence yet and utilized it because the first sentence tells me that that perimeter is 86 meters. What can I do with that? Sure, I can plug that in for P. So I'm going to put my 86 right in here for the P. But now I have 2L plus 2W. With 2 different variables, I'm not going to be able to solve that because there's nothing I can do. I'm stuck. But if I look at the second part, the second sentence here, I've got some more information that I can use. It says the length is 13 meters more than the width. Well, if the length is 13 meters more than the width, does that indicate that this long piece up here is the length, or does that mean this little short piece here is the length? If the length is 13 meters more than the width, that means the length is going to be the bigger one, the long one, and the width is going to be the shorter one down here. So I had it labeled correctly in the beginning. But what that indicates is if this length up here is bigger, what I'm going to have to do is I'm going to have to take this width and add 13 to it to create the bigger length. If I add 13 to this length, to create the width, then I'm taking something that's bigger and adding more to it to create something that's smaller. And that makes no sense whatsoever. It makes more sense to take something that's smaller, add to it to create something bigger. So in other words, I am absolutely not going to take this length and add 13 to it. I'm going to take the width and add 13 to it to create the length. So what that indicates is that I'm going to let W equal that width. Its value is not going to change at all. But my length, on the other hand, I'm going to take the W and add 13 to it. That will create that length that I'm looking for. So there's more information that I can utilize. How do I do it? Well, I just use some substitution. In other words, if this W plus 13 is the length, I should be able to take it and put it right there. And that's exactly what I'm going to do. So I'm going to go up here because I'm running out of room. So instead of 2L, now it's going to be 2L is now W plus 13. Notice that I utilized a parentheses here. The reason that I utilized the parentheses is because I'm doubling the entire length. Not just 2 times this W right here, but 2 times the whole thing, which is now W plus 13. And don't forget, back here, I also have this 2W that I need to incorporate in there. So now I've taken my perimeter formula and notice that I only have one variable. When I have one variable, I can solve the equation. So you just did the hard part. You utilized every piece of information that's in there. Now we're ready to solve it. Pretty easy to solve because we know that before we start shifting things around, we need to simplify each side. This side over here on the right is not simplified because we still have a parentheses, and we need to distribute the 2 through the parentheses to get the parentheses out so that we can move on and simplify it. 2 times W is 2W, 2 times 13 is 26, plus another 2W. Now, parentheses are removed, but I need to combine up my like terms. 2W and another 2W is going to be 4W. Now I've whittled my equation down to something that's pretty simple. I'm going to be able to solve it at this point. There's my wall. And like we said before, reversing that order of operations, if I knew what W was, I would multiply it by 4 first and then add a 26. So I got to fix the addition of 26 first. I'm going to reverse that by subtracting 26. 86 minus 26 is a 60. So now I have 60 equals 4W. What do I do at that point? Well, I'm going to take that 4W and I'm going to divide by 4. Kind of running out of room down here. And I'm going to divide by 4 here. 60 divided by 4 is going to be 15. And that's my W. But it's 15 what? Well, is it 15 yards, meters, sticks? What is it? 15 meters. There's our units. So again, be sure to include those units so that everybody knows what you're talking about. But remember, in the question it said find the length and the width. We found the width, now we need to find the length. How do you find the length? Sure, right back here. We said that all you've got to do is take that W and add 13 to it. There's going to be your length. So if I take my 15 plus 13, that gives me 28, and that's going to be my length, 28 meters. How would you check that? Absolutely. My perimeter says let's double the length, double the width. If I double this width, 15 doubled is 30. If I double this length, 28 doubled is a 56. 56 and 30 will definitely give me the 86 perimeter that I said I should have. So that's how you do number 4. Okay, let's move on now to number 5. Okay. Okay, number 5 says we're dealing with another rectangular field. This time it's 5 times as long as it is wide, and we want the perimeter of the field to be 288 yards. What are the field's dimensions? So again, with that idea that I'm dealing with a rectangle, a picture's worth 1,000 words, so I'm going to draw the picture of the rectangle. And once again, we're dealing with perimeter. That's still going to be distance around. Here's that perimeter formula that we talked about. Double the length, double the width. Now, I'm going to take it sentence by sentence very slowly so that I can see what I'm dealing with. It says that it is 5 times as long as it is wide. So once again, I've got to figure out which one's bigger. Is it the length that's bigger or is it the width that's bigger? 5 times as long as it is wide. That means that the length is bigger. So there's my length, there's my width. So in other words, that tells me I'm going to do something to the width to create the longer length. It says I'm going to do 5 times it. So in other words, I'm going to take this width and I'm going to multiply it by 5 to create that bigger length. So let's define those variables. Let W equal width. And let's let 5W equal that length. Because remember, it said 5 times the width to get the length. So like in the last one, now we can do some substitutions because this 5W now represents the length. That can go right in there. So now I'm dealing with double the 5W instead of an L, but I'm going to keep the other W in there. I'm getting closer. Now I'm down to just 2 variables. And I've dealt with the first part, the first sentence, everything that I can use in there. Let's take a look at the second sentence. The second sentence says the perimeter is 288. So this perimeter here, now I'm going to substitute a 288 in there. Now my equation looks awesome because I'm down to 1 variable and I can solve that. Not to mention the fact that I've used every piece of information that I've got in the word problem. So to solve that equation, we know we need to get rid of the parentheses. So I'm going to do 2 times that 5W. That's going to be 10W. And I know I'm going to combine up like terms. 10W plus 2W is going to give me a 12W. And we all know at this point that in order to get that W by itself, all I have to do is divide both sides by 12. And 288 divided by 12 is going to give me a 24. And that's going to be my width. Yet again, though, remember, you need to be sure that you include your units in there so everybody knows what you're talking about. 24 what? Yards was my unit. So 24 yards is going to be the width. But remember, go back and figure out what exactly did I need to find. Was the width all I needed to find? It says what are the field's dimensions. That means I need to find both the width and the length. But in order to get the length, remember, it's just 5 times that width. So I just take this 5, times it by the 24, and 5 times 24 is going to be 120. And once again, that's yards. There's my length. Just like before, we can check it, because if I double the 24, I get 48. If I double the 120, I get 240. 240 and 48, yep, 288. So I know that it's right. Okay, no, not the last one, I'm sorry, one more. So what we're going to do now is we've got a tank that contains 340 gallons of brine. I'm going to erase this now. There we go. A tank that contains 340 gallons of brine. It's being drained at a rate of 15 gallons per hour. Another tank, which starts with 60 gallons, is being filled at a rate of 20 gallons per hour. After how many hours will they both hold the same amount? This type of word problem is actually kind of a fun word problem to do. I've read it in its entirety. I know I'm dealing with 2 tanks of brine. So I'm going to draw a picture of these 2 tanks so that I can see what I'm dealing with. Here's one tank, and here's the other tank. Now, brine. Does anybody know what brine is? It's just salt water. That's all it is. Brine is salt water. Oftentimes you use brine whenever you're cooking, like if you need to soak a chicken in brine. The salt water makes the chicken a little bit moister because it retains some of the moisture in the chicken when you cook it, keep it from drying out. It's just salt water, nothing more special than that. But here's what's happening. It says that one of those tanks contains 340 gallons of brine to begin with. So here's that first tank starting with 340 gallons. Now it says that that particular tank is being drained at a rate of 15 gallons per hour. So the brine is coming out of there at a rate of 15 gallons per hour. So that takes care of the information in the first sentence. The second sentence says that the next tank is, there we go, says that the next tank starts with 60 gallons right here, and it's being filled at a rate of 20 gallons per hour. So we're sending brine in there at a rate of 60 gallons. Oh, sorry, not 60, 20 gallons per hour. My apologies. There we go, 20 gallons per hour. And we want to know after how many hours will they both hold the same amount. Well, I've taken it sentence by sentence very slowly, but now I've got to set up the equation that represents that. Notice with that first tank, being that it starts with 340, but then it says that we're draining. What happens with draining? What kind of mathematical operation is that? If the brine's coming out of it, that means when you start with your 340, you're taking out of it 15 gallons an hour. Now here's the tricky part. We know we're going to deal with that 15, but how exactly do we deal with the 15? Well, in the first hour, how much brine are we losing? Not total, but how much are we just simply losing? We're losing 15 gallons. Well, in the second hour, how much brine are we losing? Just losing 30 gallons. In the third hour, how much brine have we lost? Total brine have we lost? Not how much is left, but how much have we lost? 45 gallons. How are you getting all these? Sure, you're adding 15 every time, but what would be faster? Because what if I say like 10 hours down the road, I don't want to have to keep adding 15 every time. What would be faster? Sure, take the number of hours and multiply it by that 15. Number of hours times 15. Well, do you know how many hours this is going to take? No, in fact, that's what we're looking for. How many hours will it take for them to both hold the same amount? There is my unknown. There's the variable that I'm looking for. So I'm going to define that variable, and I'm going to say, let's let h equal the number of hours. So when we said that we're going to take that 15 and multiply it by the number of hours, I'm going to take 15 times that h. That represents this first tank right here. Now what I'm going to do is I'm going to represent the second tank. Remember that second tank, it starts with 60, and then we said we're going to add the brine in. So we're going to add at a rate of 20 gallons per hour. So just like in the last one, how many gallons of brine are we adding in the first hour? 20 gallons. How many gallons of brine are we adding in the second hour? 40 gallons. How many gallons of brine are we adding in the third hour? 60 gallons. We're adding 20 every time, but it's much faster to say, let's just take the number of hours and multiply by 20. So here's what we're talking about, number of hours, because we don't know how many it is, but we're going to take that number of hours and multiply it to 20. There we go. That represents the second tank. But now remember, we want to know after how many hours will both tanks hold the same amount. This shows how much is in there in the first tank after H number of hours. This shows how much is in there in the second tank after H number of hours. So I want these two amounts to be the same. The way that I represent that is that I want them to be equal to each other. So I've used all the information that's in the word problem. I've set up my equation. We just did the hard part, and we did a good job of it. Now all you got to do is solve that equation. And we know how to do that. We've talked about that before. So just like we've said before, we've got our wall right here in the middle. We need to get all of our variables on one side and all of our constants on the other. It doesn't matter whether you put all your variables on the right or all your variables on the left. It makes no difference at all. Most of us, since this is subtraction, we like to go ahead and add and keep everything positive. Most of us are just going to add that 15H to both sides because it'll cancel out here. I'm left with a 340. And on this side, I have a 60, and then a 20H plus a 15H is going to be a 35H. Now we put all of our variables on the right. That means get all the constants on the other side. So what I'm going to do at this point is I'm going to move that 60 out of the way. I'm going to subtract 60 from both sides. And a 340 minus 60 is going to be a 280. So 280 equals 35H. And I think we all know at this point, in order to get that H completely by itself, let's just divide this side by 35, and let's divide this side by 35. When I divide this side by 35, that gets the H completely by itself with a coefficient of 1, and 280 divided by 35 is going to be 8. And like we've discussed before, 8 what? 8 tanks? 8 gallons. There we go. Whoops, I'm wrong. It's not 8 gallons. What is it? H stood for, and this is why it's very important to define that variable, because you can go back and look at that definition that you gave on the variable to figure. It'll help you figure out what your units ought to be. There we go. And I said that H was going to be the number of hours, so it's not gallons. It's 8 hours. And again, that's a great illustration of why it's important to define your variable. After 8 hours, once this is drained 15 gallons for 8 hours, and once this is added 15 gallons for 8 hours, those two will hold the same amount. It'll take 8 hours to accomplish that. You can double check it. You can take your 8 multiplied by 15, subtract it from 340, take your 8 multiplied by 20 and add it to 60, and sure enough, you're going to come up with the same thing in both cases. You know it's right when the left and right sides of your equal sign are the same. All right, last one. Let's roll this thing down here and get the last one up there. I'm going to go ahead and erase this now. Clear that out. So in the last one, we have a rectangular swimming pool that measures 40 feet by 60 feet. It's surrounded by a path of uniform width around the 4 edges. The perimeter of the rectangle formed by the pool and the surrounding path is 248 feet. We need to determine the width of the path. Well, again, picture's worth 1,000 words, so I'm going to draw a picture of this. Here is my rectangular swimming pool. Now, remember, it says that it's 40 feet by 60 feet, so here's 40, and here's 60. Now it says it's surrounded by a path of uniform width around the 4 edges. So, there's my path. We'll pretend like it's uniform. And it's got the same, and uniform path means that this distance is going to be the same as this distance, and the same as this distance, and the same as this distance. We're going to pretend like I did a good job on the picture. Now, so we've done everything we could possibly do with that first sentence, utilized every piece of information we've got. The second sentence says the perimeter of the rectangle formed by the pool and the path. So here again is the concept of perimeter, but it's the perimeter on the outside that we're dealing with. Now remember, our perimeter formula said that we're going to double the length and double the width, and that will give us perimeter. However, this one's a little bit more complicated because when I deal with this perimeter formula, I've got not just the inside of the pool right here, but I'm dealing with the perimeter on the outside of the pool. That's what's complicating this. But in that second sentence, it says the perimeter is 248 feet. So at the very least, what I know I can do is I can put that 248 right here for that P. Now I've just got to figure out that width and that length. But again, what's complicating it is the length is all of this out here. That's the entire length. And the width is going to be all of this out here. That's the width, and this is the length. So now when I go to substitute in there, I've got a little bit of a problem because my length is not just 60 anymore. It's 60 and a little bit more. Well, how much more? It's going to be 60 plus this little length in here and this little length in here. Well, how much are those lengths? I'm honestly not sure because that is what I'm looking for right here. Determine the width of the path. So there's the unknown. There's the variable that I need to define. So I'm going to let W equal the width of the path. So remember, what that means is this is a W, and this is a W, and this is a W, and this is a W. There's going to be the width of the path. Actually, perhaps I should call it an X instead of a W, because now I've got way too many W's in there. Let's go with our proverbial X that I usually like to dodge, but I think this time the X is going to be pretty helpful. Let's go back and get that W out of here, and let's call each one of those an X instead. I think that'll be a little cleaner and make a little more sense. So X here, X here, X here, and X here. So, like I said, this length that I see right down here, it's no longer going to be just 60, but now it's going to be 60 plus this and 60 plus this. So the length is now going to be 60 plus an X plus another X, which X and X is going to be 2X. There's the length that we're dealing with in that perimeter. So like we said before, that is something that we can substitute right up in there. Now, let's take a look at that width concept. So with the width, what's going to happen is it's no longer just this 40 that's right here. It's going to be 40 plus this piece and 40 plus this piece. So that width is going to be 40 plus one of the X's up here and, plus the X. My apologies. There we go. 40 plus the X that's up here at the top, and then the other X that's down at the bottom, add it in as well. That's the full length that we have on the outside over here. And we know that 40 plus X is going to be 40 plus 2X's. That's going to be the width that we're dealing with. And just like we said before, we can take this and we can substitute it right in there for that W. So now my perimeter formula is going to look like 248 plus 2 times now this length, which is 60 plus 2W. Not W, but X. Again, I'm so sorry. There we go. And right here, plus 2 times now this W right here, which is 40 plus 2X. So now, good grief. Phew. I've got a big old mess on my hands, don't I? So 248 equals 2 times 60 plus 2X plus 2 times 40 plus 2X. I took all this information and just substituted it right here in this perimeter formula. But notice the cool thing is now I'm down to just one variable, an X. That's it. So I can solve this equation, and we've discussed before that when you solve that equation, you need to get rid of all the parentheses first and shave that side down, simplify it as much as you can. So I'm going to distribute the 2. Remember, only distribute it to the end of the parentheses, not beyond that. 2 times 60 is 120. 2 times 2X is 4X. And I'm going to distribute here as well. So 2 times 40 is 80, and 2 times 2X is 4X. Now I need to combine up all my like terms before I go any further. So I'm going to combine up my 4x and my 4x. That'll give me an 8x. And then I'm going to combine up my 120 and my 80, and that'll give me 200. And now to solve that equation, I think we all got it at this point. I'm just going to simply subtract that 200 and subtract that 200, and that'll give me 48 equals 8x. And then we know at this point what we need to do is we need to take both sides and divide them by 8. And 48 divided by 8 will give me 6. And like we've discussed before, 6 what? What is that dealing with? Remember, the x is going to be the width of the path. So what are the units on the width of the path? We're dealing with feet everywhere through here. So it's going to be 6 feet, and that is the distance of the path. Go back and double check in the problem and say, is that what I was supposed to find? Is that the answer I was looking for? And sure enough, it is. Determine the width of the path, 6 feet. So that's how you do number 7. And so that's a good illustration of all the different types of word problems that you could encounter, at least in this particular section as we work through our first unit in college algebra. So get into my math lab and go practice this and lift weights in that weight room. Have a good day.